Two six-sided dice are rolled and the outcomes are noted. Give a sample space of equally likely outcomes. So one way to approach this, or at least how to organize all of this, would be to think of, okay, the first die we could get 6 different outcomes. We could get a 1, a 2, a 3, 4, 5, or 6. And then based on each of those, the second die we could get, again, 6 different outcomes. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And so each of these would be, we could, this first outcome would be getting a 1, then a 1, or then a 1, then a 2, or getting a 1 and a 3, a 1 and a 4, 1 and a 5, 1 and a 6, and so on. You could go through all the different outcomes like this. But this is kind of, it's 36 different outcomes. 6 times 6, there's 36 different outcomes here. Let's think of a different way that we could express that. Well, if instead of thinking of it like a tree diagram like I did over here, let's think of it using a chart. And so what I'm going to do here is set up a chart with 6 columns and 6 rows. And my location in the chart is going to tell me, I'm going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And more or less arbitrarily, I'm going to say the number where we are, kind of the horizontal location, is going to be representing our first die. And then the vertical location is going to be the second die. Really what I'm thinking of there is the kind of the XY notation we saw with graphing. But if I do that, then this box right here would represent 1, 1. This box right here would represent 2, 1. Yeah, 2, 1. This would be 3, 1, 4, 1, 5, 1, 6, 1, all the way up through, 4, 6, 5, 6, 6, 6. You can see there's 36 different boxes here. And this is a nice, easy way, one way that we can represent a sample space when we're talking about rolling 2 dice. Now, if we wanted to take this up to 3 six-sided dice, we'd have to add a third dimension on there. We could do, do a cube, or kind of make this a 3-dimensional graph, and talk about there being 216 different outcomes or something like that. Yeah, I don't know. There's different ways you could do it, but we're not really going to worry about that in this class. We're going to be doing this 2 six-sided dice. We're going to do it fairly frequently. So frequently, in fact, that I've supplied a resource, a dice and card chart. Let me pull that up. So here's the dice and card chart. We'll be using cards as well, a decent amount, when we're talking about some of these probabilities, so it's nice to have that card chart here. But the dice chart, you can see there's actually 4 different versions of this. This was intended to be printed off, so you could do 4 separate versions. But yeah, you can see there's this 6x6 box or grid or whatever. You can use those, you can look at those. I have them available on MyLabs Plus, so just go on there and you can look at them. And that's something, yeah, you might want to print it off so you can use it during a test or something along those lines. That is something that I explicitly allow during a test, though. So let's talk about what the probability of some probabilities here. What is the probability that the sum of the dice is an 8? So I'm going to use the chart that I've started to draw up here. The nice thing about when you have a chart like this is that there's certain patterns that appear. So if I fill in a couple of additional numbers here, you can see here I get a sum of 1. Sum of 2. The sum of 3 occurs here and here. A sum of 4 would occur here, here, and here. This would be 1, 3, 2, 2, 3, 1. And so what we end up seeing is that we get sums, equal numbers occurring along the diagonals. And that actually kind of makes sense if you think about it. If I started out at 6 with a 1, if I decrease the second die and increase the first die, thus getting to 5, 2, I would still have the same sum. Decrease one, increase the other, I would, basically moving along these diagonals, I would end up with equal sums. So if I was to look for where I have an 8, a sum of 8, well, let's see, 6, 1 is here, 6, oh, no, that's not 6, 1, that's 1, 6. 1, 6, 2, 6. So I have a sum of 8 right here. And based on how this is set up, I know that 3, 5 is going to be right here. That's going to have a sum of 8, 4, 4, 5, 3, and 6, 2. So those 5 values, those 5 different events, or 5 different outcomes, I should say, 5 different outcomes have a sum of 8. So if I was to define what E was here. If I'm trying to find the probability of 8, E is going to be the event. I get a sum of 8. And E is going to be what? These outcomes. 2, 6. Yeah, I'm not going to write it like that. I'm just going to write 2, 6. 2, 6, 3, 5, 4, 4, 5, 3, and 6, 2. Now, these are not the same event. Getting a 2 then a 6 is not the same as getting a 6 then a 2. That's why I can have them both in the set here. Of course, 26 and 62 is how I've written that, but I'm going to think of it kind of the way it's written on that other chart. I guess I said I wasn't going to do this, and here I am doing it. Whatever. All right, so the probability of E, the probability of getting a sum of 8, well, there's 5 different events where we got that sum. There's 36 total events, so I have here n of E over n of S. Maybe I should write that out. N of E over n of S, which was 5 over 36. This being a fraction, you'd probably want to look to see if you could reduce it. You could convert that to a decimal, but I don't really see any reason to, so I'm just going to leave it as 5 over 36.